All right, so we've talked about how to classify polynomials based on degree. So we've talked about linear, quadratic, cubic, quartic. Does that sound familiar? You can also classify by the number of terms or the number of pieces, okay? And that's what these are. Now, this should not come as a huge shock to you. What is a monomial, do you think? Yep, mono means one, so a monomial has one term. Well, this is not a good stylus. Okay? So like 3x, that's a monomial. If I just had 3x by itself, that would be considered to be a monomial. What's a binomial? Two terms, yep. So like 2x squared plus 5. That'd be a binomial. And then what's a trinomial? 3 terms, okay? So like a quadratic in standard form is technically a trinomial. So like 4x squared minus 3x plus 2. That's a trinomial. Okay, 3 terms. It doesn't have to look like that. I mean, it's anything with 3 pieces to it. Okay. These examples that we did up here on the board, this is a binomial, this would be a trinomial. Okay. Our final answer came out with 5 terms. Nothing beyond trinomial gets a cool name. All right, so we would just say that's a 5-term polynomial. Okay. Just so you know about degree, and I can't remember if I mentioned this in the video for you guys yesterday or not, but if a term, or if a polynomial has more than one variable in it, so remember there was that one example in the notes that had like p and r? Remember how for degree you look for the biggest exponent? Well, if the terms have more than one exponent or more than one variable, the total degree is the sum of the exponents, and you'll see what I mean by that in a minute. Okay. And then the total degree of a polynomial is the biggest total of all of the terms. We'll do some examples in a second. I'll show you. Okay, so I've got a couple of examples here. I want you to classify it based on the number of terms, and then we're going to give the degree. So how many terms does that first one have? 3. So we would call it a trinomial. Yep. Okay, and see how like each one of these pieces has more than one exponent in it? So what I'm going to do is I'm going to add up the exponents in each piece. This one would be a 12. This one would be a 13. Can you see where I'm getting that from? Okay. And then this one, 3 plus 6, would give me 9. So of those 3, which one's the biggest? Yeah, this middle one, right? So we would say that the degree is 13. And by the way, if I were to go write it in standard form, this is the process I would use. I would go, here. I would go this one, and then this one, and then this one. So I want to go in descending order of these numbers. Okay? So when an exponent, or when a term has more than one variable in it, add the exponents together. Okay, how would you classify this next one? Binomial, yep, 2 pieces. So this would be a binomial. And then in this term, what's my total degree? 2 and 2 is 4. What's my total degree here?
6.
Good. Where are you getting 6 from? Yeah, that x really has a 1 on it. Don't forget that. So 5 and 1 makes 6. So we would say our degree is equal to 6. And if I wanted to write this in standard form, I would do this term first and then this term. Okay? Does that make sense with degree? Okay. All right. You're going to see problems like this on your homework tonight and even more tomorrow. So what I'm really looking at here is I want to look at this as one big rectangle. Okay? I know it's broken down into littler pieces for you, but I'm really thinking about the rectangle as a whole. And I want the dimensions of the rectangle. What does dimensions mean? What am I asking you for? Okay, yeah, kind of how many boxes. If I asked you for the dimensions of this classroom, what would you tell me? Like the length and the width, right? You would give me the measurements. That's what I want here, too. I want to know how long is this side and how long is this side. Well, what would I say? Okay, but I have numbers here. So I see where you're getting to by whatever you said, but using these, what could I say the total length here is? What would you do with those two things? I'm not multiplying them. There it is. It's 3K plus 12, right? Wouldn't you add these pieces together? Okay, so my first dimension is 3K plus 12. I heard some 15Ks. I see where you get that from, but what's wrong with making that 15K?
12 doesn't have a K.
12 doesn't have a K, so I can't mix them. All right, so that dimensions question is a lot easier than it looks, right? What would my other dimension be?
2K plus 6S plus 7R.
That's it, 2K plus 6S plus 7R. Those are your dimensions. Now, find the area of the rectangle. What do you think we're going to do?
Solve.
And by solve, you mean?
Do it.
Multiply. Isn't that how you find areas? You multiply length by width. Okay. If you wanted to, you could, this is set up for you just like what we did yesterday. So you could take the 3K and distribute. You could take the 12 and distribute. Since this up here, though, is kind of set up in that box method for me already, I'm going to go ahead and use that. And that way, those of you who haven't been able to see this yet can see that box method in action. Okay? So what do I get when I do 3K times 2K? 6K squared. How about 3K times 6S? Good. 18KS. 3K times 7R. Good. Everyone else following this too? Okay. 12 times 2K. 24K. 12. What's that?
Nothing.
I got to finish it. 12 times 6S. 72S. And 12 times 7R. 84R. Good. Anything here that can be combined? I don't think so. Unless you see something I don't. So when I go to write my final answer for my area, I'm just going to combine all of those. Now, a standard form on this one, let me blow this back. I'm going to talk about standard form for a second. Standard form on this one is a little bit tricky, okay? Because I've got a bunch that have a degree of 2. Like, for example, 6K squared, that has a degree of 2. But then 18KS, if those are both 1s, this one also has a degree of 2. And this one also has a degree of 2. And then all of these would have a degree of 1. Does that make sense? Where I'm getting that from? All I really care about right now is that you have the 2s before the 1s. Okay? As far as standard form goes. Typically what you do, the way you do like a tiebreaker if you have more than one with the same degree, is you go by the first letter in the problem. So I would go by the K's. And so since this one has more K's in it, I would start with this one. And then these two have the same number of K's, so I would go to my next letter in the alphabet, which would be R, and that'd be this one. But I don't want to get too stressed out about that right now. I want the 2s before the 1s. That's what I care about. Okay? So I would say for my final answer, 6k squared plus 18ks plus 21kr plus 24k plus 72s plus 84r. That one's kind of weird because they had so many different letters going on in there, but that's how you would do it. Cameron?
Since they're all 2, why couldn't you go by the first number and then like 21, 18, 6?
We don't really ever go by the coefficient. I'm not sure why, but it's not really this number that we care about. It's more the exponents that you care about. So if you had done that, again, as long as you had these 3 before these 3, it would be fine. Okay? But yeah, just for whatever reason, when we're talking standard form and degree and all that, we're way more worried about the exponents. So, example 3. I want you to read this question for a second. Take a second and just read it. And let's see, I'm going to need a black pen here. Okay. This is one of those problems. This reminds me of the picture frame problem in, what was it, chapter 6. Do you remember that problem where it was like, here's a picture, here's a frame of width W, give an expression for the total area. And you had that problem over and over and over again, and every time it worked the same way and the numbers just changed. But every time people would say, oh my gosh, I don't know how to do this problem. That's what this is like. You're going to see this problem over and over and over again in this chapter. And I think probably even on the final exam. And every single time the process works the same way. Okay? So here's what this is talking about. And I'm going to try to give you sort of a visual here too. I've got a sheet of cardboard here that is 30 centimeters by 45 centimeters. And what I'm going to do is I'm going to cut off the corners. And those corners have a length of x. So like this is x, this is x, this is x. So you get the idea. And so now what my sheet really looks like, let me be really slick here. Now what my cardboard looks like is this. Can you envision that if I folded here and here and here and here, that this would make like an open top box? Can you see that? That these would be like your flaps on the box. And then this open rectangle down here, this would be like the bottom of the box. It's the box without a lid, but it would make a box.
Seems way too much explaining for something
Okay.
simple, probably.
Well, I just want you to see where the picture comes from, because algebraically this is where it gets confusing. How do I find volume of a box? It's the easiest volume you ever do. Multiply what?
Width times height.
Say it again.
Width times height.
Times something else. Length. Yeah. Volume of a box. Write this down if you don't know it.
It's been a while since I've done that.
I know. A whole year. Length times width times height. Okay. So my box. You think that was too much explaining? I'm actually going to miss this box. Okay, so there's my box, or there's my cardboard. If I fold it here and here, and here, and here. This is a high quality box here. Okay, there's my box now, right? So my length is this right here. And in my picture, it would be like this line right here is my length. What's the length of that green line? Perfect. Yes. it used to be 45, right? If I went all the way across, it would be 45. But I cut off these corners and folded them upward, right? So the length of my box is now 45 minus 2x. Can you see why it's 45 minus 2x? Because I took off an x on either end. So now the width of my box is the short side, right? The width of my box would be this. What's the length of that side? 30 minus 2x. What is the height of my box? What is this? Good. Yes, that's x. Okay, because the height of my box would really be like this, which matches up with like what I tore off here at the corner. So my height would be x. So now let's go back to our formula. I want to do length times width times height. So I'm going to do, v equals 30 minus 2x. Hold on, scratch that for a second. I need some more space. My length was 30 minus 2x. Oh, maybe my length was 45 minus 2x, but doesn't matter. And the height of my box was what? X. So I need to multiply these three things together. Here's what I would do. I would multiply these two, simplify that as much as you can, and then just multiply through by this x at the end. Okay? Now this is just FOIL, right? So 30 times 45, oh, I'm going to need your help with that. 2350?
No, 1,300.
1,000, okay. 1350. Okay, 30 times negative 2x is negative 60x. Negative 2x times 45 is negative 90x. And what's negative 2x times negative 2x?
4x squared.
Good, positive 4x squared, right? I'm going to clean that up a little bit. I'm going to combine the 60 and the 90 in the middle here. All right, so I'm going to say 1350. 60 and 90 makes 150, so this would be minus 150x. And then plus 4x squared. And then what do I still have left that I need to multiply by? That x at the end, right? Now that's actually really easy, because that's just a monomial down there. That's just one term. So all I really have to do is distribute. Okay, so I'm going to take this x, and I know it looks backwards from how you usually distribute, but I'm going to do x times this, x times this, x times this. I end up with 1350x minus 150x squared plus 4x cubed. So pretty much I just tack an x onto everything. Now, should I go back and write that in standard form? Technically, yes. But if you can get to there, I'm happy. Okay? Those problems are going to, I know that seemed complicated. Those problems are going to work the same way every time. This setup is going to be exactly the same every single time. It's going to give you two numbers in the problem, and your setup is going to be blah, blah, blah minus 2x, blah, blah, blah minus 2x, and x. And then you multiply them. Every single time that problem comes up, it's going to look exactly the same. Does that make sense? I hope so. Okay.